Okay, folks, we've got to really go back to Friday. And on Friday, we were given the 1.6 graded homework, 1.516 graded homework. Which problem did we go over together on that one? It was like 6 or 7. It was 8. We went over 8 together. Um, 4 and 8 we went over together. And then we'll go over one more today before we hand that in. So if you want to look over it and find out which one we can try to come to a consensus on. But Friday we did that. Then we came back Monday and we took the STAR assessment. Now I haven't even looked at the results yet. I could really care less what the results look like as far as the class goes. Again, as I explained, it was just kind of a hoop we had to jump through. So I will look at the results, and if there's any type of printout or anything like that that I can hand to you, I will print those out and hand them out to you. I don't know what it means, but you took it. If I took something, I'd want to see how I did on it. So if there's anything that I can print out for you guys to see, I will do that. And then yesterday we had the day out. So today, then, is when the 1.516 graded homework will be due. Afterwards, we'll get into 1.7. I have a parent-teacher conference with my son tomorrow, so I won't be here for your guys' class. So tomorrow's going to kind of depend. If we get 1.7 done today, then you will be working on the homework assignment in class tomorrow. You'll use that 40 minutes to work on the homework assignment tomorrow. If not, then I will probably record the rest of the lesson, going through the rest of the notes, looking at a couple more examples, and then after the video, you'll then start the 1.7 assignment. So tomorrow kind of depends on where we get today. Ultimately, 1.7 is the last section of the assignment. Okay, so at the very latest, you watch a video tomorrow that finishes 1.7. The assignment is due Friday. That puts Monday and Tuesday at what? Pre-test and tests. Okay. Regardless, it's going to be Friday and Monday. I'm sorry. If we finish today and you have tomorrow in class to work on the assignment, then it would be Friday, Monday. Okay, so you've got to prepare that we will finish today. We'll be looking at Friday, Monday. If not, it'll be Monday, Tuesday. That test will cut the first marking period, which I think ends next Friday anyway. I think it ends the 9th. Okay, so this test will be the last grade. So right now you've got the 1.5, 1.6 graded homework, the 1.7 completion, and then the test, these last 3 grades to go on the first marking period. Questions on where we're at right now? Okay, let's go ahead and take a look at that 1.5, 1.6. Now you said we did 4 and 8 together. Is there a consensus on another problem we'd like to look at, Jen? Jen's got 5. We've got 9. Any others? Okay, so let's see a show of hands for 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That tops it. So we'll go with that one then. 5. Find the inverse of the function in number 5. Explain to me then, please, what is the process to find the inverse of a function? You switch x and y and solve for y. Well, what we've got to recognize here, though, is that they don't have x and y. They have f of x. What is f of x? F of x is y, but ultimately when we switch it back, we can't leave it y. We've got to turn it back to f negative 1x. So when we switch, what are we going to get here? X equals negative 2, y minus 7 over 6y plus 8. Now, if I've got a fraction over here, I might as well make it a fraction over here. Okay. How do we solve a proportion? So what's x times 6y plus 8? 6xy plus 8x equal to negative 2y minus 7. Now, what do we need to solve this for? Y. So we need to get our y terms over on the same side and everything else to the other. What will the the left-hand side look like then? 6xy plus 2y equals negative 8x minus 7, or 7 minus 8x. Ultimately, does it make a difference? No. It's the same thing. So now what can I factor out of this side? And if I factor the y out, what are we left with? 6x plus 2 equal to the negative 8x minus 7. And now can I divide to get y? We've got our negative 8x minus 7, and we're going to divide that by what? 6x plus 2. But again, we don't want y. We want to go back to function notation. This represents our inverse. What is the inverse notation? F negative 1 of x. So this corresponds back then to which choice? C. That corresponds back to choice number C. Letter C. Okay. Okay, make sure you got your name and date. Name and date on the assignment. Make sure you drop them off with me then as you leave. Now, Dean, you had a question on 9. If you want... Okay, and I'd gladly go over with you tonight on study session. Now, with study session tonight, folks, I'm assuming I'm not going to be back by 7. So give me 7:45, 8 o'clock to get on tonight. Okay, if you want to get onto the study session tonight, give me at least till 7:45, 7:45. Okay, so I can get the kids back home and probably bathe to warm them up and into bed. Okay, so give me 7:45 if you want to get on tonight, and I'll gladly go over with you. Okay, Dean? Okay, folks, let's move on then into 1.7. And again, all I need is your separate sheet of paper. I do not need the worksheet as you hand them in. I just want the separate sheet of paper. Okay. So on the separate sheet of paper, make sure you've got your A, B, C's, and D's on those as well. Okay. Really not any new learning in 1.7. We're just going to use functions to model some real-world type situations. Okay, using functions with modeling. Okay. And now, again, there's 3 types of models that we have. What are the 3 types of models that we have? We have a graphic model. Give me an example of a graphic model. We see them quite often in Algebra 2, and we see them pretty much in every section in pre-calculus. What would be a graphic model? An example of a graphic model. We use them to write regression equations. We first graph, though, a scatter plot. Scatter plots would be an example of a graphic model. What's the second type of model? An algebraic model. An algebraic model is just the rule. F of x equals 2x squared minus 4x plus 5. That's an algebraic model. What's the third type of model? A table. We call that a numeric model, and a table of values is a good example of a numeric model. Okay, so we're going to use modeling with functions, any type of the 3 models with functions. Let me quickly go through the quick review and see if there's anything we want to highlight out of these, and there are here. For homework tonight, I'm going to give you, if you look to the wiki space here, your homework tonight, some of it is the quick review. So you're going to see some of the questions like what we're seeing right here. Sometimes the quick review in the notes is exactly the same as the quick review in the text. But you're working out of the exercises and the quick review for homework tonight. So the quick review is going to be similar to what we see right here. Okay? Solve the given formula for the given variable. Solving literal equations. Very, very important skill in mathematics. Even more important in the science fields. And Ms. Shifley and I have discussed this a couple different times. Are you always solving for the A? Are you always solving for what your formula has it solved for? No, quite often you're not. It's a very important skill that you can work backwards and solve for one of your other variables. Okay? So if they wanted us to solve for the height here, how would we solve for the base? How would we get rid of this 1/2? So it would be 2a equals base times height, and then we would, so our base would be equal to 2a over h. Again, folks, I cannot explain to you enough the importance of being able to solve literal equations. Okay, we're going to have a lot of these formulas where we're going to have to make substitutions back and forth. And a lot of this is connecting the dots. What information do I know, and how will that information help me in someplace else? Another thing I want to highlight out to you, open up your books, front covers and back covers. What do you have on your front covers and your back covers? Formulas and important things. Are all these formulas found either on the front or the back covers? Yes. Are these ones in front or back? I guess they'd be scattered kind of about, I guess, but they're all there. Okay, so if you've got a formula you're not quite sure of, check your covers of your book. Chances are it's there. Okay. Volume for a cylinder is volume is 1/3 pi r squared h. They want us to solve that for h. So again, how would we get rid of the 1/3? So 3 times of the volume would be pi r squared h. And then what do we have to divide by to get h? The pi r squared. So the height would be 3 volume divided by pi r squared. Okay. Do we need to go with any further with these ones? Do you get the picture? Okay. What's that? Yes. Your quick review is basically going to be very similar to this right here. Okay. And then we got that done. So let's go ahead and get into this. Now, again, there's really no learning in this, folks. This is just connecting the dots. What do we already know? How can we apply what we know? Okay, and I think we've looked at this problem before. Have we made the open top box before? Yep, by cutting the squares out. Okay. So it says a square of side x inches is cut out of each corner of an 8 by 15 piece of cardboard, and the sides are folded up to form an open top box. Can everybody visualize this? So we cut here, 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 and here. We fold along the dotted lines. We tape the edges. We formed an open top box. Okay. A, write a volume, or write the volume as a function of x. Well, folks, volume is a function of how many things? And I guess let me start my questioning somewhere else. How do you find the volume of a box? Length times width times height. So volume is a function of how many things? 3 things. It's a function of the length, the width, and the height. So as we start this out, we've got to say that volume is a function of length, width, and height. And it is equal to what? Length times width times height. So volume starts off as being a function of 3 variables, your length, your width, and the height. But they said that they want this to be strictly a variable of x, one function, or one variable, a function of one variable. So what we've got to do is determine somehow our width, our length, and our height, all in terms of x. And so they said x represents the corners that we're going to cut out of this, what was it, 8 by 15 sheet. So this here originally was 8. This over here originally was 15. And originally our height was what? 0. Originally our height is 0. Does this sheet have a height? No. Okay, so width. What did we do to the 8? We cut off 2x. 8 minus 2x. What did we do to our length? Cut off 2x. 15 minus 2x. So now we've got our width and our length in terms of x. That's good. And our height is x. That's what we're going to cut up. Okay, so our volume was a function of 3 variables, length, width, and height. But then we said, okay, length is 15 minus 2x. So length is a function of x. Our width is 8 minus 2x. So width is also a function of x. And we said our height is x, also making that a function of x. So now can we go up and replace the length, the width, and the height all with variables of x and turn our volume as a function of 3 variables into a function of 1 variable? Yes. So now we're going to say volume strictly as a function of x is equal to what? What's our length? 15 minus 2x. What's our width? 8 minus 2x. And what's our height? X. Did we satisfy what they want us to do for part A? Write the volume as a function of x. Have we done that? Yep. Volume is a function of x, and it's equal to the product of these three things. Do we need to simplify it? No. Could we simplify it? Yes, we could, but we don't need to. We're not going to run into the algebraic errors. We've got it set up. Let's not simplify it down. Okay. But this would be a what degree polynomial? If we did multiply it out, x would be to the third power. This would be a third degree polynomial. It would be a cubic. And it would be a positive cubic because a negative times a negative would give us a positive x squared times an x would give us a positive x cubed. So it would be a positive cubic. It would have this general shape to it. Does it necessarily have to have these maximum, though? Because the general cubic just looks like that. So it could potentially have that max and min, but it doesn't necessarily have to. Can everybody visualize this? Part A is taken care of. Part B, they want us to find the domain of this function. Okay, well, in terms of this cubic, what's the domain of a cubic? All real numbers, but we got to put this into the context of this problem. Can x be negative numbers? Could x be greater than 8? No, we couldn't cut it out. So we've got to put the domain into the context of this problem. What would be the smallest value of x? We couldn't really use it, but it would be a boundary for us. 0. Are we going to include it, though? No, because if x was 0, would we have anything to fold up? No. What's the maximum that x could be? Why 4, Dean? How did you get 4? You got to make 2 cuts, right? So it can't be more than half of the smallest side. What's our smallest dimension? 8. Half of that is 4. But could it be a cut of 4, though? No. So why do we do part B? Well, because we're going to eventually solve this graphically. We're going to be solving this equation graphically. They're going to want to find, in this case, what's the maximum volume, but look back into what we did in the prerequisites chapter. I think what we were looking at was what dimensions would give a volume of 1,250. So we set it equal to 1,250, and we graphed it. We didn't solve it by hand. We graphed it. Well, that's why we're finding the domain. X values can go from 0 to 4, not included. Can't be any larger than that, can't be any smaller than that, or we won't get a box. So that's going to help us when we go to graph this to solve it. So here's part A. Here's part B, our domain. X values from 0 to 4. C says to graph the function, graph V as a function of x over the domain found in part B and use the maximum finder on your grapher to determine the maximum volume such a box can hold. So part C, we're going to say on grapher, and we're going to have a max volume of, and not only of what, but at x equals what. So what is the max volume and what is the value of x that gives us that max volume? So into the calculator. Into y equals. We will type in parentheses 15 minus 2x. Close open 8 minus 2x. Close open x close. Okay. 15 minus 2x times 8 minus 2x times x. Let's set up our window. We said values of x, we're going to go from where to where? 0 to 4. Probably ought to scale that off by once. This is fine. What do the y values represent? The max what? Volume. The y values represent our volume. Well, if we didn't cut any dimensions out of this box, what would be the volume of the box? 0. Can you have a negative volume? No. So that one's always going to be a 0 there. But the max volume, we don't know what the max volume is. So let's just throw something in, and if it's enough, it's enough. If it's not, it's not. We'll go 500. I'm going to scale that off by 50s. And we can clearly see here that 500 is way too much. So I'm going to narrow it down. So there's 50, there's 100. I'm going to go to 150. Looks like 150 would scale it off good. And now we'll scale it out by 15. So it's a good exercise. Are you always going to come up with a good window right off the bat? No. So we put in what we get, and then we adjust it. Is that a much better graph now? Yes. Now we can clearly see the maximum. We can use our calculator to find the maximum. So how do we find the maximum here? Second, trace, option. Option 4. They want a left bound. Is my spider to the left of the maximum yet? So we move it to the left. I'm definitely to the left right there. I hit enter. Now they want me to move it to the right. I'm to the right. Whoa, stop. Stop. I'm to the right, and I'm going to use that as my guess as well. Okay. So we have a max volume of, and now it's not in the context of the problem, and they haven't otherwise stated. We're going to round this to 2 decimal places. A max volume of 90.74. 90.74 what? Did they give us units? Inches. So inches cubed, or cubic inches, at x equals, what is it, 1.67 inches. So from the grapher, we have a maximum volume of 90.74 cubic inches when x equals 1.67 inches. All right, with part C? And then D, how big should the cutout squares be? So have we answered that as well? Yep. We've answered C and D together. I never give a maximum or a minimum without also giving the value of x that it occurs at. Is it always necessary? No. But I always like to put it on there just to show when it occurs or where it occurs at. Questions on that problem? Again, a question I said that we'd be seeing again. Where are we time-wise today? Miss DeLong, what time do we? Thank you very much. So we got a good 15 minutes still. Okay, so here they're just going through the individual parts of the problem. So we graphed it, found that maximum. One and 2/3 to 1.67. Okay, how about this one? Grain is leaking through a hole in a storage bin at a constant rate of 5 cubic inches per minute. Something to highlight. 5 cubic inches per minute. Cubic inches is a measurement of volume. It's a measurement of volume. The grain forms a cone-shaped pile on the ground below. As it grows, the height of the cone always remains equal to its radius. That's a key part right there. The height equal to the radius. If the cone is 1 foot tall now, how tall will it be in 1 hour? Notice up here they're talking about per, and they want to know how tall it will be in an hour. What type of a figure are we looking at here? We're looking at a cone. Here's that cone-shaped pile. And from the context of the question, we're looking at what to do with that cone. Five cubic inches per minute was a measure of volume. What do we want to find for this cone? We want to find the volume of this cone. Well, the volume of a cone is a function of its radius and its height. And it's equal to what? What's the volume for a cone? Pi r squared h over 3, or 1/3 pi r squared h. It's 1/3 the volume of a cylinder. A cone is 1/3 of a can. 1/3 pi r squared h. Okay. The grain forms a cone-shaped pile around the ground below. As it grows, the height of the cone always remains equal to its radius. So they said that h is equal to r. So instead of having this function be a volume of radius and the height, can I turn it into a function of 1? Does it matter if I use the height or the radius? No. But look at the context of the question. They ultimately want me to know a height. So I'm going to turn the radius into height. So volume, strictly as a function of height, would be 1/3 pi. The r gets replaced with h squared h, or 1/3 pi h cubed. 1/3 pi h cubed. It says right now the cone is 1 foot tall. So at this instant in time, h is equal to what? 1 foot, which is how many? 12 inches. Right now the height is 12 inches. So can I find the volume of the pile right now? Yeah, absolutely I can. So the volume as a function of 12 is equal to 1/3 pi 12 cubed. Now let's try to leave this in terms of pi. So cube 12 and divide it by 3. And tell me what you get. 576 pi? 576 pi cubic inches is the volume of the pile right now. They want to know how tall will it be in 1 hour? Well, we know that we're gaining how much per minute? So 5 cubic inches times 60 minutes would equal what? 300 cubic inches per hour. So in 1 hour, we will have gained 300 cubic inches. So what will our new volume be? Volume will now be equal to 576 pi plus 300. And we're going to set that equal to pi, or 1/3 pi h cubed, allowing us to solve for what? H. Okay. So how will we get rid of the pi over 3? By 3 over pi. Either divide by pi over 3 or multiply by 3 over pi. So 3 over pi times 576 pi plus 300 is going to be equal to what? H cubed. And then how will we undo the cube? So h is going to be equal to the cube root of 3 over pi times 576 pi plus 300. Now can we go to calculator? Yes. Okay, so cube root. Where do we get cube root? Math 4. Now we would need to add another parenthesis, 3 divided by pi. Close the 3 divided by pi. Open 576 pi plus 300. Close that quantity. Close the cube root. Tell me, what is the height? And now, do we have anything in the context of the question that would tell us what to round it to? No, they gave us a rate, but they didn't give us any measurements. So h is equal to 12 point what? Inches. Inches. Height is just measured in inches. Okay. So did the height of the cone increase much? Take a look at that, though. I mean, we added 300 cubic inches. Is that a lot? It's a good amount. 300 cubic inches. But ultimately, it only increased the height and the radius by how much? Yeah, less than an inch. Almost 2/3 of an inch. Okay. Does that make sense, though? Is that reasonable, though? Yeah, I mean, is that, picture it. Thinking of a gravel pit. When that gravel comes off, it forms those cone piles. Do those piles get very big? No, they get wider this way. Okay, not much taller as you go, but they do get wider. So is this reasonable to the problem? Absolutely it is. A lot of connections that we've got to make here, though? Absolutely. Anything mathematically you've never seen before? No, it's just connecting the dots. And folks, that's what pre-calc is about, is connecting the dots. This here is really a calculus problem, folks. You just did a calculus problem. Okay, it's connecting the dots, being able to see what's going on. They're talking about 5 cubic inches per minute. That's a measure of volume. They're talking about a cone-shaped pile. What's the volume of a cone? Volume is 1/3 pi r squared h. But then they said the h and the r are the same thing. Could I have taken this in terms of the radius as well then? And made it 1/3 pi r cubed? Yeah, absolutely. Okay, and then what information do I have? Well, I have right now that the height is 12. So knowing that the height is 12 right now, I can find the volume. And I know how the volume is changing. So after that time, I can find out what the new volume would be. And then using that new volume, can I determine what the height would be? It's all connecting the dots, folks. What do you need to help you along the way? Formulas you need to help you along the way. What else? Diagrams to help you along the way. Okay. Was there anything we did here mathematically difficult? No. It was just being able to connect the dots. Visualizing, writing the formulas down, writing what we know helps us connect those dots. Okay, questions on that problem? Okay, is there another one for us at all? Constructing a function from data, creating scatter plots, determining the shape of the plot, whether it's linear, exponential, logarithmic, quadratic. Make it fit that one as close as possible. So here they're trying to get into regressions on this one. So linear, quadratic, cubic, quartic, natural log, so on and so forth. We've seen these before. Exponentials, powers, logistics, sinusoids, so on and so forth. Okay. So if it fits, depending on what your scatter plot looks like, if it looks like a quadratic, then we do a quadratic regression. If it looks like this, cubic. If it's got this M or this W shape, quartic. If you're not sure, could you do a few different regressions and find out which one's the strongest? How do you determine which one's the strongest? No. There's a number that will tell you which one fits best. Correlation coefficient. We want it to be closest to 1 or -1, whichever one's strongest. So if you're not sure, and folks, there's going to be ones where it may be power, quadratic, or exponential. You're not sure. We'll do a couple regressions, find out which is the strongest. Okay, run through them and find out the strongest. Over here, they kind of give you applications of when you would use these ones. Okay, so linear, fixed costs, projectile motion for quadratics. We talked about those ones. Volume type problems are cubics. We looked at just 2 volume problems up above. Those ones are cubics. So on and so forth. Logistic growth would be like populations. Exponential growth, interest in an account. Something like, or radioactive decay. Newton's law of cooling, temperature, loss of a cooling body. So you take a lasagna out of the oven. You can tell what I want for dinner, huh? You take a lasagna out of the oven, the lasagna cools, according to Newton's law of cooling, which we'll talk about in Chapter 3, but that would be an exponential type of model as you go through those. Okay. So we have covered then the section. There are no other notes, right? Okay, so let me take you into the homework assignment. I would recommend getting a start on it tonight. Don't plan that you're going to get it done in the 40 minutes of class tomorrow. Okay, so get a decent start tonight. And you're going to have questions, folks. Plain and simple, you're going to have questions. Okay, so what I want you doing tomorrow is working in preferably pairs, groups no bigger than 3. Okay, pairs or groups to help each other through the problems in your questions. So it'd be nice to have a good start, a good base, to be able to bounce your questions and your ideas then off of your partner or your two partners. So on page 160, we're going to do the quick review, 2 through 10, the evens. So that's these ones up here, 2 through 10, very similar to the ones that we did in the quick review on the lesson. So 2 through 10, the evens. It's just solving literal equations. They're going to have a formula that they want you solved for a different variable. Okay? 2 through 10, the evens. And then in the exercises, 3 through 48, the thirds, 50 and 51. 3 through 48 thirds, 50 and 51. Okay? So have a start on it. Have some questions for your partner to bounce some ideas off of. And then hopefully you can complete it in class tomorrow. This will be due then Friday for us. No. Yes, tomorrow's Thursday. Yes, this will be due Friday. We'll go over questions Friday. We'll look at the practice exam Friday. And then Monday will be tests. Okay. Again, give me till at least 7:45 tonight if you want to get on to study session. And then tomorrow will be study session as well. Regardless if I'm here or not, I'll still hold to the review sessions. Okay? So tonight, give me till 7:45. Tomorrow we'll be on regular, and then practice test Monday, and practice test Friday, test Monday.